Consciousness refers to an awareness of the self and the environment. The self refers to your own thoughts and interoception, like internal stimuli such as hunger or tiredness, things like that. And the environment refers to exteroception, so external stimuli, like things that are around you, things you see, things you hear. While this definition has changed a lot throughout the years, reflecting philosophical and scientific advancements, uh, consciousness has always referred to an awareness of some kind, and many non-human species do show consciousness, like primates, even spiders, bees, etc., do show some degree of consciousness, which seems to suggest it's an adaptive trait. But exactly how consciousness works is largely unknown. So we definitely think this is like an evolutionarily advantageous adaptation. Being able to pay attention to only the most important stimuli and ignoring things that don't matter is very useful. Species that are better able at doing this kind of thing do tend to be more successful in a lot of different ways. And some species are definitely better at doing this than others. So consciousness, you might just be able to describe that simply as an evolved form of paying attention, right? So there's this attention schema theory that explains how the brain can better attend to important stimuli by constructing a simplified model of its own processing. However, it remains unclear if what we call consciousness has any real survival value. The experience of consciousness, this thing we refer to as consciousness, might be a kind of spandrel, like a non-adaptive byproduct, like evolutionary leftovers from this real advantage of being able to select what to pay attention to. Now, the thing about consciousness is that it's not binary. There are varying degrees of consciousness that people will go between on a daily basis. But some consciousness is much higher than others. So like low awareness, low consciousness refers to automatic processing of stimuli and reflexive responses. So like if you detect a light source and you look towards it, that's pretty low level of awareness. Most species can show that level of consciousness. But higher levels of awareness require some degree of effortful decision making, such as, for example, realizing the light source is unimportant and choosing to ignore it. Now, like I just mentioned, an individual's level of awareness at any given time can vary based on many factors, such as the kind of stimuli that's being processed, the individual's state of mind, and how intelligent the individual is. But definitely some animals tend to operate on lower levels of awareness than others. So just to be clear, low awareness refers to the automatic processing of stimuli and reflexive responses. Now, some species, this is pretty much all they can do, like a sea sponge or a sea star or a jellyfish. They don't really show any signs of anything but the most basic kind of consciousness. And this kind of consciousness can be influenced by various really subtle factors, like memory cues, for example, physical stimuli in the environment that have some particular significance to the perceiver and will elicit a behavioral response of some kind. Cues can even have implicit, meaning like subconscious, beyond your awareness, effects via a phenomenon called priming, where the perception of memory cues allows related thoughts and feelings to come to mind more easily. So, like the subliminal messages, if you've ever heard about that phenomenon, that's how that works, is through this priming. Now, to try to figure out what's going on in a person's low awareness or low consciousness is not so easy because a lot of it is implicit. It's beyond your level of awareness, conscious awareness. So we've had to come up with fairly creative ways to figure out what's going on in there. And one way in particular is called the Implicit Association Test, or the IAT. This measures people's reaction time for various stimuli in order to try to measure these automatic assumptions people make. For example, if somebody were to be a racist, they might be quicker to press a button to identify an individual as black if that same button was also being used to identify words as being bad words. And there's a lot of variations of the IAT for measuring all kinds of associations. It's not just for racism, they've got variations for all kinds of things. But the point here is that we can use these kinds of things, like the implicit association test, to try to figure out what kind of content is in this low level of awareness. So here's an example of how the IAT works. So you would want to instruct the participant to push the left button if they see a black person or if they see a bad word, and the right button if they see a white person or a good word. So they'd flash it on the screen like this. Crime is bad, you would push the left button. Next stimulus, okay, that was a black person, so you push the left button. Love, most people would call that a good thing, so you push the right button. And here is a white person, so you push the white button. So what I'm saying here is if you have a implicit dislike towards black people, you should be very fast to make these kinds of judgments. But when we flip it around, here, let me just skip past this. When we flip it around and now the left button is black or good words and the right button is white or bad words, now people who are racist against black people are going to be a little bit slower because it takes them a little bit longer to realize, okay, that I just saw the word crime, but I want to push to the right button. You know, they might instinctively go left because they have that implicit association making them a racist, but they then have to like correct themselves and push right. Now that would be a left button. This would also be left, and once again they'd be a little bit slower, right? So this is just one example, but this is a very famous, a very popular and well-known example of how you can measure what's in that low awareness, specifically these kinds of implicit associations. Now, there's no single brain area responsible for this kind of low level awareness. The primary regions that are responsible for these lower levels are the brainstem and the limbic system areas, specifically things like the dorsal pons, the sensory cortices, which are not shown in this illustration. Those do just basic sensory processing. The thalamus, which does sensory relay and attention. The basal forebrain, which does arousal. The interior insular cortex, not shown here, which does like basic emotional processing. And these areas are important for processing sensory information. That's basically what they do. And that basic processing of sensory information is what low level awareness really is, if you think about it. On the other hand, high level awareness, what I said about that earlier is that this requires effortful decision making. So the person is using mental effort to make meaningful decisions about stimuli. And humans can obviously do this, but many other species can too, like cephalopods, for example. You know, like squid, like octopus. Sorry, I meant octopus. They can operate at this level, but they don't always do so. So organisms that can achieve high levels of awareness, they don't do it very often, actually. Because when you're using this mental effort to make meaningful decisions, you're going to get tired eventually. It does become very taxing on your brain and your body to constantly be making these high level decisions. There's this thing that you can achieve at the high level called mindfulness, which is this state of heightened focus on thoughts that are passing through your head, as well as the more controlled evaluation of those thoughts. Like maybe you'll think about something Maybe you'll be taking that implicit associations test and you realize, hey, does this mean I'm racist? And then you think about your thoughts and you try to correct yourself. Like, I don't want to be like that, right? Like, I need to not be thinking in this kind of, like, if you can do that, you're at the high level of awareness and you're practicing mindfulness. You're trying to evaluate your own thinking and potentially change it. But like I said, that takes a lot of effort. So people don't often do that. And when you aren't, trying to focus on your own thoughts, then you do generally default back down to those lower levels of consciousness. So what I was just describing, this use of mindfulness, can be explained with the flexible correction model. This is one particularly important skill that we see within high-level consciousness, that ability to think about your thoughts and then potentially alter them if you do not agree. So that's what the flexible correction model refers to, is this ability of people to alter their beliefs if they believe those beliefs have been biased, if they determine their beliefs have been biased. So I've already given plenty of examples. Here's another one. If somebody realizes they only thought their day was great because it was sunny, they might revise their evaluation of the day to account for this biasing influence of the weather. Just because it was sunny, that doesn't necessarily mean it was a great day. Just updating your previously held beliefs. But like all high-level thoughts, as I've been saying, this requires effort, and that requires a lot of energy. And people just tend to be kind of lazy, so they tend to not do this kind of thing as often as you would hope. Now, the brain areas that are involved in high levels of awareness are the same brain areas involved in low levels of awareness, except for a few. So once again, there's no like single area responsible for more advanced forms of consciousness. It does require those like basic sensory areas like the thalamus and all that. But you also have specific areas that we only really see when people are engaged in that kind of high level consciousness, like the prefrontal cortex, which does a lot of exteroception, processing of external stimuli, and the insular cortex, which does interoception, or processing of like internal stimuli, like what's going on in your head, what's going on in your body, stuff like that. But then there's one structure, one very special structure that seems directly associated to high levels of consciousness. It's called the claustrum, and that is what we associate with the ability to focus on things. So the thing that really separates humans from a lot of other animals is that it's not that we have these areas, because a lot of other animals do. It's that these areas are much more highly developed in humans, and they're very important when it comes to social skills. But it's that claustrum in particular that I wanted to go into a little bit more detail on. Like the prefrontal cortex, I've basically said everything I need to say about that. It does play an important role in high levels of consciousness. We just don't know how important, maybe not actually that important, but the prefrontal cortex is definitely involved. At least the posterior regions. The anterior regions don't appear to be all that involved, but the posterior stuff does play a big role when it comes to like socio-emotional aspects of conscious awareness and stuff like that. So there's a lot of conflicting evidence, but it definitely seems important to some degree. Just to remind you, anterior means towards the front, whereas posterior means towards the back. So it's those more back-facing areas of the prefrontal cortex that seem the most important when it comes to consciousness, like higher levels of consciousness. And then that insular cortex, I talked a lot about that in the previous chapter. This largely has to do with interoception and empathy and social processing and stuff like that, especially the anterior insular cortex. It's much more heavily involved in awareness of social emotional stimuli like empathy, whereas the posterior is more heavily involved in awareness of stimuli from one's own body, like somatosensation, muscle movement, balance, even thought. But as I was saying earlier, it's the claustrum that seems to be the most interesting here. it's especially important. It's this very small, thin group of brain cells you can find right about here. It's just tucked right behind the insular cortex, and it connects the brainstem to the cerebral cortex. What the claustrum seems to be doing is it seems to be allowing the brain to focus on more important stimuli by acting as kind of like a conductor. It's often described as something like a conductor. It coordinates this complex pattern of neural activity. And as a result, we have the experience of these higher levels of consciousness. In fact, this is the most heavily interconnected group of neurons in the brain, which has made it especially difficult to study. Like when you look at the claustrum, you see it's connected to the thalamus, like sensory processing, basal ganglia, various like sensory cortices in every lobe of the cerebral cortex. It's connected to the frontal lobe, it's connected to the motor areas, it's connected to the prefrontal cortical areas. It's got tons and tons of connections. So the result is that if you're engaging that claustrum and those other high levels of high level processing areas, then you're able to think about things and think about your own thoughts on a much deeper, more meaningful level. But like I said earlier, you don't always do this. It definitely requires a lot of energy. So as a result, people aren't always at that high level, especially since there are things that could potentially knock you out of that ability to think about things in that deeper way. Like you might experience what you could call an altered state. Minor changes in how this network, um, interacts with various brain areas could produce an altered state, like, how many psychoactive drugs can affect a person. But more major changes in this network could completely eliminate what we call consciousness. So this is what could induce an unconscious state in an individual. But like I was saying, this happens all the time. People are constantly going up and down when it comes to the level of consciousness they're experiencing. I think a good metaphor for this is, think of consciousness like a dimmer switch, like, those light bulbs where you can like turn it up and turn it down to however bright you want it to be. Well, just imagine you're doing that with a very limited amount of energy. So you don't want to leave it on full bright all the time. You want to only turn it up as much as you absolutely have to. And then when you're not going to use it, you turn it back down again to conserve energy, right? So you would only turn it up if you really, really had to focus on something, if you really had to illuminate, to see something, right? And definitely you're going to turn that light off completely when you're going to bed. Like you don't need any real level of consciousness if you're not going to be processing stimuli in any meaningful kind of way.